Okay, this is a Unit 3 review packet, topic 8b, graphing a system and stating solutions. So I'm going to go over how to graph by hand, but then I'm going to do most of them on the calculator. So I'm going to graph one of the linear ones by hand. I definitely would suggest you graph the quadratic ones on your calculator. So this first one's linear, but in order to graph it, I need them solved for y. So the second one is solved for y, so I can graph this one right now. Right? I know my m, my slope, is -6, and my b is -1. So remember for linear, I'm looking at y equals mx plus b. I want them in that form because my m is my slope and my b is my y-intercept. And when I graph, that b is my starting point. So here my b is -1. That is my starting point. Then I use my slope, and I'm going to actually write it over 1. I use my slope of -6 over 1 to move from that starting point and find other points. So I would go 1, 2, 3, 4, 5, oh, I'm off the graph, down 6 over 1. So if you're off the graph, realize that down 6 over 1 is the same thing as up 6, left 1, right? -6 over 1 is the same thing as 6 over -1. So this one is saying down 6, right 1. This one is saying up 6, left 1. So because I'm off the graph going down 6 to the right one, I'm going to try going up 6, 1, 2, 3, 4, 5, 6 to the left one. So here is my first line. And you can see, I mean, I'm off the graph, but you can see here if I went 1, 2, 3, 4, 5, 6, down 6 over 1, I'd be here at this point too. This one is not solved for y. So to get this one solved for y, I'm going to divide everything by -4. So this by -4, this by -4, this by -4. That gives me y equals -6x minus 1. It's the same line. So that means I have the same line, one line on top of the other line, and that is infinite solutions. All the points are in common. Because remember, for a system, my solution is where they intersect. But if it's the same line, they intersect at every single point. So I have infinite solutions when it is the same line. And again, you can see it's the same line before you even graph it. Same line. All right, let's graph one more by hand. So I have y equals x. So again, I want to pick up my m and my b. My slope is the coefficient of x, which is 1. And I don't have anything after it. That means my b is 0. This one, my m is the coefficient of x, which is 3/2, and my b is 5. So on this first one, my starting point is my b, which is 0. And I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. I'm going to get a bunch of points. And there's my first line. My second one, the starting point is at 5. So 1, 2, 3, 4, 5. And then I'm going up 3 over 2. But again, as I talked about in the first example, up 3 over 2 is the same thing as down 3 to the left 2. Right, a positive by a positive is a positive, but a negative by a negative is also a positive. So I don't have space to go up 3 over 2, so I'm going to go down 3, 1, 2, 3, left 2, down 3, left 2, down 3, left 2. And you can see on this one that it's still a positive slope, right? That's what I want. 3/2 is a positive slope. This line is still going in a positive direction. Unfortunately, my graph is not big enough, and I can't see the intersection on this one. I can see they're not parallel. They're going to intersect somewhere down here. So I'm going to need to do this one on my calculator. So we're going to go to y equals, and whether you graph by hand or graph on the calculator, they need to be equal to solve for y. So y equals x. And then y equals 3 over 2 x plus 5. So let's hit graph. And I can see even here, they're barely touching on my graph down here. So remember, on my graph, if I want to calculate the intersection, it's second calc. I'm calculating the intersection. So it gets, when they're one intersection, which this is just going to be one intersection, they're lines, it's not as important, but if you have more than one intersection, it's important to be near the intersection. So it's a good habit to get into, to kind of move your cursor near the intersection. And it tells me my intersection is -10 negative 10. So there's my answer. So again, second calc, 5. I moved near it, I hit enter for first curve, enter for second curve, enter for guess, and there's my answer. So let's try this one, which is 2 quadratics. Again, it needs to be solved for y before I put it in my calculator. So on this one, I need to divide everything by 2. So when I divide everything by 2, I get 1/2 x squared minus 3x minus 9/2. And this one I get y equals negative 1/2 x squared plus x plus 1/2. So again, I'm dividing everything. 1, 2, 3. There's 3 terms. Everything gets divided by 2. Same thing here. Everything gets divided by 2. So I go back to y equals. I'm going to put 1/2 in, so alpha fraction 1/2 x squared minus 3x minus alpha y equals again 9/2. And then my second one, alpha y equals negative 1/2 x squared plus x plus alpha y equals enter 1/2. So again, I like alpha y equals enter because it looks like a fraction. If you don't use alpha y equals, you need to make sure that you're putting your fractions in parentheses when you put them in your y equals button. So let's hit graph. We'll see what that looks like. It should be 2 quadratics. And we can see that they intersect in 2 spots. So we're going to have to do second calc intersection twice on this one. So move close to the first intersection. I'm going to do this one first. First curve, enter. Second curve, enter. Guess, enter. And here's my first answer. Negative 1, negative 1. Let's go to the second curve now. So second calc, or the second intersection, 5. We need to move toward this one or else you're going to get the same answer again. So you got to move to the intersections when there's more than one, or it's just going to keep giving you the same. So I'm going to move close here, hit enter for first curve, enter for second curve, enter for guess, and my intersection is 5, negative 7 on this one. Now, if I wanted to do a quick sketch, the easiest way to do a quick sketch is to use my calculator to get some values. So I'm going to go to second table, and then I have y1, that's the first one I put in, and y2. So let's see. I don't want to get numbers that are too big here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I can do these. So negative 3, 1, 2, 3, 9 would be here. I'm not going to graph fractions, so I've got negative 1 is here. 1, negative 7, 1, 2, 3, 4, 5, 6, 7. And then I've got 3, 1, 2, 3, negative 9. I need to go see some more values. 5, negative 7, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. And lastly, 7, 5, 6, 7, 7, negative 1. And then I have 9, 9. So you can see this first one goes like this. If I want the second one, I'm going to look at the y2 and get some values off of that. So let's see if I can get some small values that I can graph. So we've got negative 3, negative 7. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. We've got negative 1, negative 1, which is one of our points of intersection actually. We've got 1, 1, so 1, 1. We've got 3, negative 1, so 1, 2, 3, negative 1. 5, negative 7, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, that's my other intersection. And that's about all I'm going to do here that's on this graph. So, whoops. So there's my graph of that one, and you can see my intersection points. Whoops, I didn't do a great job of graphing that one. So my intersection points here, if I had done a better job of connecting these dots, that's 1 right there, and that's 1 right there. So negative 1, and 5, negative 7, and I got those points right from my table. Okay, last one. We need to solve for y. So this first one, everything gets divided by 2. So y equals squared plus x minus 5. So that was 4 divided by 2, 2 divided by 2, negative 10 divided by 2. This one, I just need to move over that 2x. So when I subtract 2x from both sides, I get negative x squared minus 2x minus 5. I go to y equals once they're both solved for y, and I put them in. So 2x squared plus x minus 5 for the first one, negative x squared minus 2x minus 5 for the second one. Hit graph, see what they look like. Okay, so it looks like they intersect down here, and it looks like 2 spots. So second calc intersection, I want to be near the first intersection. Hit enter for first curve, enter for second curve, enter for guess. It tells me it's at -2. Wow, that does not seem right. You know what, let's zoom in. I'm going to do a zoom box actually, so we can see what's going on in this area a little bit better. Alright, so that's zoomed in on the area of intersection. Oh, no, it's definitely in 2 spots. Alright, so let's try again. Second calc number 5. Let's get close to the intersection. So first curve, second curve, guess. Let's try the second one. Second calc intersect. Let's go near this one. So first curve, second curve, guess. So here we go. This intersection tells me it's -1, -4. That seems right. Let's try this other one again. I'm not sure why it's doing that. Second calc intersect. Go near this second point of intersection. Enter, enter, enter. 2.083 times 10 to the -14 and -5. So if y is -5, I guess it's saying it's really close to 0 on this one. So what we want to do is probably check the table, because what this is saying is 2.083 times 10 to the -14 is a number that's super close to 0. So in reality, this is 0, -5. We can quickly check that on the table. So I want to find -5. Oops. I want to find -5 on the table, and yes, it is at 0. So note, if you get a number like this, a number that has like times 10 to the -14, times 10 to the -15, go back and check your table and see that, yes, it's actually at 0. So this is just saying 0. So my 2 points are -1, -4, and 0, -5.